Welcome to a new lesson. In this lesson, we'll be discussing properties of functions. The set of first elements of a relation is called the domain. The set of related second elements of a relation is called the range. Let's take a look at an example below. The following example is called an arrow diagram. It relates 1, 2, 3 to 1, 4, 9 by squaring it. Meaning, if 1 is squared, the result is 1. If 2 is squared, the result is 4. And 3 is squared, then the result is 9. The first set is called the domain, while the second set is called the range. This information can be put into ordered pairs, where the first term is the domain, while the second term is the range. Specific parentheses are used for this purpose. So let's take a look. 1 is related to 1 because 1 squared is 1. 2 squared is 4. 3 squared is 9. A function is a special type of relation where each element in the domain is associated with exactly one element in the range. The first set is called the domain, and the second set is called the range in this example. The example asks and relates number of wheels to the type of vehicle the wheels contain. For 1, we have a unicycle has 1 wheel. A bike and a motorcycle have 2, while the tricycle has 3 and a car has 4. A function is a special relation where each element in the domain is associated with exactly one element in the range. Because the 2 is associated with 2 vehicles and not just 1. Therefore, this is not a function. This example is not a function. It is just a relation. If you, in the other example, flip the order, it's a different story. Now we associate the bikes and the types of vehicles as a domain, while the wheel number as the range. In this case, when we draw the lines, we'll always get one domain for one range. So take a look. Bike has 2, car has 4, motorcycle has 2, and tricycle has 3, unicycle has 1. A relation again, a function is a relation where each element and domain is associated with exactly one element in the range. In simpler terms, each vehicle has exactly one type of wheel. Well, not type of wheel, but number of specific wheels. Before, in the example, the type of wheels had a possibility of having different vehicle types. But now we have vehicle types that can only have one specific type of wheel configurement. Let's take a look at function notation versus equation. What you're used to having is an equation with 2 variables. Now we're going to have a specific function notation which means exactly the same thing. It means the following. V of x is equal to 2x plus 3. I want to show you how to use this in calculations. Suppose we have x is equal to 1. We would then solve for v. What would be v, the value? So 2 times 1 plus 3 will give the value of 5. Let's use the same type of operation with function notation, except we're going to write it a little bit differently. So now we're going to write v bracket 1. We're not going to multiply it. I'm just going to put it inside the bracket and plug in for the x value. Notice now v of 1 is 5. Now that's a little bit different in writing than v equals 5. Let's use this knowledge in the next couple examples. For each relation below, determine whether the relation is a function. Justify the answer. Identify the domain and range for each relation that is a function. So let's take a look at A. A relation that associates given shapes with the number of right angles in the shape. So we have a right angle, we have an acute triangle, we have a square, a rectangle, and a regular hexagon. There are 1, 2, 3, 4, 5 distinct, in our order pairs, domains. These are our domains. Since all of these domains are distinct, they're different, and they're not repetitive, it's a function. Now let's take a look at part B. Oh wait, we probably have to go back and find the domain and range of the function. So given the ordered pairs, the domain is considered the first element in the ordered pair. So domain is the right triangle, acute triangle. So we have acute triangle, square, rectangle, regular, hexagon, and domains. Basically, it's just the elements in the first location in the coordinate point. As for the range, it is all the second element in the coordinate points. Usually when we write the range and we have numbers listed, it's best to write them in ascending order. So 0, 1, 4. Now let's take a look at part B. So now we have two elements, the domain, not elements but two sets. The first set is a domain and the second set is a range. Let's see if this defines a function or a relation. So let's take a look at the first element, a 1. Now, this domain has two ranges. It has a range of -1 and it has a range of 1. Because of this fact, this is not a function. Because we have to have a unique domain for each range. In other words, 1 is repeating. And also, 4 is repeating. Also, 4 and 1 have two ranges for one domain value. So that's why it's not a function. Let's take a look at the next example. The table shows the masses, m, in grams, of different numbers of identical marbles, n. Is this a relation or just a function? Identify the independent variables and the dependent variables, justify your choice, and write the domain and range of the function. So the question is this a function? So what if this was an arrow diagram? For each number in the first column, there is only one number in the second column. Because of this, it is a function. Yes. Now let's talk about these independent and dependent variables. If we look at the table, we notice that one marble is 1.27 grams. 2 marbles is double of it. 3 marbles is triple it, quadruple it, and multiplied by 5, multiplied by 6. So the mass of the marble is dependent on the number of marbles. So therefore, our mass of the mass is dependent on the number. So our independent number is the number of marbles, while the dependent variable is the mass of marbles. Now, the last part, what is the domain and range? Since we know our independent-dependent variable, the independent variable is always considered the domain, D, while the dependent variable is considered the range. So let's list our domains. So we have 1, 2, 3, 4, up to 6 marbles, and their range, or the masses, are 1.27, 2.54, and so on, up to 7.62. Make sure you close the brackets. Let's take a look at the next example. The equation V is equal to negative 0.08 D plus 50 represents the volume, V is in liters, of gas remaining in a vehicle tank after traveling D kilometers. The gas tank is not refilled until it is empty. Describe the function and write the equation in a function notation. A function notation, all it requires is a V bracket and the variable or the letter that you are using inside the equation. And since it is D, we write D inside the bracket. That is your function notation. To describe this scenario, we know that the volume of gas tank, of gas remaining, is a function of the distance traveled. And that's part A for you. What about now for part B? Determine the value of V of 600. Well, this V of 600 means that we're putting into D the distance of 600. And we're solving for this equation, for V of 600. Negative 0.08 times 600 is negative 48. We add plus 50 to it. Therefore, negative 48 plus 50 is 2. And what is 2? 2 means that we have 2 liters remaining in the gas tank.